would that help you pay attention better? Okay. It's really taking way too much time to get this started. Feeling like an elementary school teacher. Hey, come on, you guys, pay attention. Hey, come on, you guys, pay attention. You guys are in high school, not elementary. We're in high school here. That's where you try to be a little more mature than what you're actually doing. Okay?
Because we don't have a playground.
So, measures of central tendency are mean, median, and mode. Write that down. Those are the three measures of central tendency. Mean, median, and mode. All of which I know you've heard about, so I don't think we'll need to spend a lot of time on this. What's another word for mean? All right, write that down. The mean is the same thing as the average. You add up all the numbers and divide by how many there are. Yes? That's what you guys were taught, hopefully. Median, what's another word for median? Middle.
Oh, you know how I remember that? I have a trick to remember that.
What's your trick?
Median, that sounds like comedian, and they have to be the center of attention.
Mode? What's the mode?
Most common.
Most often occurring number? That's the mode.
Oh, yeah.
Mean is the average, the median is the middle, and the mode is the most often occurring. The one thing that you might not remember about mode is there could be more than one, okay? Or there could be no modes at all in a set of data. If no numbers occur more than any other number, there isn't a mode. If there's 2 or 3 numbers that occur with the same frequency more than anything else, then they're all the mode. These are all considered measures of central tendency. Now you got to think, if we did some kind of a survey and polled, I don't know, 10,000 people, where would most of the data lie? Where would the most common data points lie? Let's say we polled people on their height, and we polled 10,000 people. Wouldn't most people be of average height? Okay, so that would be, if we listed all the numbers from shortest person to tallest person, wouldn't most of them be right somewhere in the middle? Okay. Where would the most often occurring height be? Towards the end points or somewhere in the middle? In the middle. What about the median? Where's the median going to be? Obviously, in the middle. That's why all 3 of these are considered measures of central tendency, because when you get a sufficient number of numbers to look at, most all of these are going to be right smack in the middle or pretty close to each other. They're called measures of central tendency. Okay? You guys got that? Okay. Oh, you need books. Let's have this row pass them out. You guys are the book passer-outers. Distribute. Look at this efficiency. You guys are getting your workout in today. We should have had you stretch first. You're going to pull a hammy. Oh. This is a model of efficiency. Everybody needs a book. Page 4. Page 4. At the end, we're at the beginning. Okay, so take a look at the top of page 4. You see problem 1, got it? Read through it real quick. Read through the problem 1, got it on the top of page 4. They've organized the data into the table. It's kind of interesting, kind of hard to understand unless you've seen one of these before. It's called a frequency table. So just read the problem and look at the table, see if you can make any sense of it. This is the problem 1. Got it. Top of page 4. You see the table there with trees and yards? How do we make sense of that table? What are they even talking about?
How many yards have that many trees?
Is that what you were going to say? Did you guys hear that? How many yards have the certain number of trees? Thank you. So I've got the table copied down here. One of the yards, so these are all yards on one single street. So 1 yard had 3 trees, right? 5 yards had 4 trees. 7 yards had 5, and so on and so on. Do you understand how to read this now? This is called a frequency table. It's nice for identifying the mode. If you take a look, what's the most often occurring number of yards or number of trees per yard? You guys see what I'm saying? The most often occurring number of trees per yard is 5. There's 7 yards that had 5 trees. So if you were to look at this data, what would you say the mode is? 5. The mode is 5. Okay? That's what they're asking us to do on this problem, isn't it? Find the mean, median, and mode. So we found the mode first. What would you guys suggest doing to find the average or the mean? So what are we adding up?
5 4s, 7 5s, 4 6s, 7.
Did you guys hear that? You're not just adding 3 plus 4 plus 5 plus 6 plus 7 plus 8. You're adding 1, 3.
But it's not saying there's that many trees for that many yards. Like it's not. It's per 5 trees for 5. That means that one of them can have no trees.
Wait, say that again.
So it's saying it's not for. So say for the first one, it's saying that there's 1 yard on the street that has 3 trees, and then the next street has 5 houses, and all there's 4 trees that has to split up evenly into those.
Well, I think these are all yards on the same street, if I read it right.
Yeah.
Isn't that how it reads?
It says on Grove Street.
That means that each house
How
has
many yards have that many trees?
Okay, gotcha.
So they obviously live in an HOA and they have to have trees. Don't you love those HOAs? They're such a pain. Yeah. So anyway, back to what I think Cameron, weren't you saying this? It's not just 3 plus 4 plus 5. It's how many 3s are there? There's 1 3. How many 4s are there? So there's 1 3. There's 5 4s. There's 7 5s you're adding up. So that's one thing you have to do, but then you have to divide by how many. What are we dividing by? Because you don't just find an average by adding things up. You've got to divide by how many numbers we're adding, or how many yards we have. How many yards do we have? We have 20 yards. So why don't you take a minute and see if you can calculate the average number of trees per yard for this one street. Average number of trees per yard. The mode was 5. And since these are all measures of central tendency, we're guessing that the average should be pretty close to the mode. So what'd you get? 5 1/4? That is correct. The average is 5 1/4, 5.25. Let me show you a couple different ways you could write this, and I do need you to write both of these because I'm going to use both of them later. So hold on now. You can write this one of 2 ways. You've been given the table as a frequency table, but you could write it like this: 3. Then how many 4s should we have? 5. So we've got 5 of those. Then we got 7 5s, right? Yeah. 3, 4, 5, 6, 7. How many 6s?
4.
1, 2, 3, 4.
1, 7.
1, 7, and 2 8s. I need you to have this list somewhere in your notes. Write that down real quick. We're going to use it in just a second. Now, since there's so many repeated numbers, it made more sense to put this in a frequency table like they did instead of just a list of numbers like that. Raise your hand if you've heard of a stem and leaf plot. That's kind of like a frequency table in some sense. So if the frequency table was kind of difficult to understand, you could just write them all out. You could add all those numbers up and divide by how many numbers there are. There's 20 of them. So you could do it that way, or you could write it like this: 3 plus, what are there, 5 4s, plus 7 5s, plus 4 6s, plus 1 7, plus 2 8s. Couldn't you write it like that? And then divide that by 20. So you could have written it that way as well. But the reason I had you write it in order is now we've got to find the median. Median or middle. The average was 5 1/4, and the mode was 5. How do we find the median? Yeah, one common way is to cross out the outsides until you find your way to the middle. But it depends on if you have an even number of numbers or an odd number of numbers. We have 20 numbers up here, right? So there isn't actually one number right in the middle. There's actually 2 numbers in the middle. You guys follow? Exactly. So if you have 20 numbers, you count 10 in on either side. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That puts me right there. And then count 10 in on the other side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That puts me right here. So both of these numbers are right in the middle. That doesn't mean they're both a median. You only have one median. So usually those would be different numbers. You'd add them together and divide by 2. So what number is right in the middle of 5 and 5? 5. So 5 is the median. Okay. Now I said before we started that all 3 of these are considered measures of what? Central tendency. Because quite often the mean, the median, and the mode are very similar to each other. Because in a large set of data, most of the occurring numbers are going to be right in the middle, causing that to be the average, the median, and the mode. You guys with me so far? Now, I'm kind of skipping ahead a little bit here to the last topic, but I think it would make sense to talk about it now. Look at what I had you write for topics. What was the last topic? Percentiles. Has anybody heard of that phrase before, percentiles? It's different than percentage. Okay? Some of you scored 90% on the last test. That's a percentage. That's not a percentile. Okay? What's the difference between a percentile?
It's all the people.
It's...
Oh, I know.
It has to do with a large group. What do you think?
Percentile, it can like be changed, and there's like more like it's based off other people's scores, like a lot of people have, but then percentage is like a set. You know, you have to go to.
Okay, I see what you're saying. You're right.
People who, like if you're talking about test scoring, that's the percent of people who scored lower or mistakes.
Did you guys hear that? So let's say that let's say that you took a test, a national test, and you got a letter back saying, "Congratulations, you scored in the 50th percentile." Does that mean you scored 50% on the test?
No.
What does that mean?
50% of people got lower.
That means 50% of people got lower than you, 50% of people got higher than you. That's what the 50th percentile. What if you got a letter back that said you were in the 90th percentile? You scored better than 90% of the people who took that test. So a percentile has nothing to do with your actual score. It's more of a ranking, right, in order. So if this is called the median, what percentile do you think the median is? 20 guys, think. Where is the median? Right in the middle. What percentile would be right smack dab in the middle? So the median is also called the 50th. I want you to write this 50th percentile. It's right smack dab in the middle, the 50th percentile. So if you wanted to have a number of trees that put you in the 50th percentile of this data, you'd have to have 5 trees. Okay? Now do this for me. Put a box around the lower half of the data, like that. And then put another box around the upper half of the data, like that. So the 50th percentile splits the data into a lower half and an upper half. You guys follow? Okay, now listen carefully to this before you blurt out an answer. If the 50th percentile is the middle of the whole entire data set, what would be the middle of the lower half? The 25th percentile. You guys follow? So if we just considered the lower half of data, what would right in the middle of that be? The lower half of the data. Well, how many numbers do we have? 1, 2, 3, 4, 5, 6. We have 10 numbers. If you count 5 in, 1, 2, 3, 4, 5, and then count 5 in, 1, 2, 3, it'd be right in the middle of those two numbers right there. What's in the middle of those two numbers? So this would be called what percentile?
25th.
This is the 25th percentile. It's kind of like the median of the lower half of the data. Now do the same thing for this one right here. What would you call right in the middle of this set of data? 75th. It's right in between this 6 and that 6 right there. So it'd be 6. Yeah. Okay, since these three values are used quite often, the 25th, the 50th, and the 75th, they've been given their own special names. The 50th percentile obviously is median. Okay. The 25th percentile they call Q1. It stands for quartile. If you're breaking things up into 25, 50, and 75, aren't you breaking it up into quarters? So the 25th percentile, we call it quartile 1, or the first quartile. The median is referred to sometimes as quartile 2, not very often, but it's called quartile 2. So then the 75th percentile would be called quartile 3, or Q3. I'm going to be using those a lot, or we're going to be using them a lot today. Q1, Q3, and Q2. Okay. You guys still with me? Now, if all three of these are pretty close to the same value, why do we need 3 measures of central tendency? Why don't we just stick with 1? What's the next topic I had you guys write down after this? Outliers. Okay, what if for some reason there was some freak on the street that had 49 trees on their property? Okay. Now, hold on a second.
This is what's known as an outlier, because 49 is significantly different than the rest of the number of trees per yard, right? Now, this is, you guys need to try to understand this. This is the reason that they have 3 different measures of central tendency. When you have outliers like this, it changes some of these measures. So I want you to think about this real hard before you put in an answer. If I put an outlier of 49, is that going to change the mean, the median, or the mode for this set of data? What's it going to change?
Or is it going to change all of them? Is the middle of the, even with the 49, isn't the middle still 5?
Yeah.
Isn't the most often occurring still 5?
Yeah, so the only thing is the mean.
And does it change it a little bit? It did, yeah. But even if it did, it would change from 5 to 6, so it wasn't a huge change. But does it change the average significantly? Actually, do this real quick. If you can, add up all 21 of those numbers. I'm just curious how much it affects.
It's 7.3.
Changes to 7.3?
Yeah.
Okay. So, I mean, it doesn't seem like a big jump, but if you were to look at this data and find the average, is it a very good estimate to say that the average number of trees on that street is 7.3 trees per yard? Is that a true reflection of the average number of trees per yard? No, it's because of this one outlier here. In that case, you wouldn't really consider the average as a measure of central tendency. You would either use the median or you would use the mode. You guys following? another case in point, if you were to look at the Saratoga Springs website, they give you demographic values like number of residents, population demographics like number of ethnicities and that sort of thing. One of the data points they give is the median household income. Okay. Why do you think Saratoga Springs website chose to give the median household income on their website and not the average household income?
There's a few that make a lot more and a lot less, so the average wouldn't probably be that accurate. Maybe you can get to better.
Well, it's like what you did with the test score, dropping to 0 because it doesn't really accurately portray how we did on the test.
Did you guys hear what both of them said? There are a few residents of Saratoga Springs that make significantly more than other residents of Saratoga Springs. So if they were to calculate the average and put that on their website, would that be a true reflection of what the quote-unquote normal Saratoga Springs citizen earns? Probably not. So they chose to go with the median. So knowing if you have outliers in your data set is important because that helps you decide which is the most accurate measure of the central tendency. So that brings us to our second topic here, outliers. Your book has a really weird definition of outliers, so I'm not liking that definition. Take a look at the top of page 5 and read through that thing. Top of page 5 in your book. It's not incorrect. It's not very accurate, though. So according to their definition, how would you define an outlier? Is it very clear on how they define an outlier? It's not real clear, is it? But just give it your best shot. According to that definition, what would you call an outlier? A number that's different than the rest? Well, aren't all numbers different than other numbers? You know what I mean? How do you tell how much different a number is from another number? So there needs to be a way to quantify how quote-unquote different a number is than other numbers. So if you take a look at, I think it's your A practice number 3. Take a look on page 5, the A practice number 3.
Copy those numbers down in numerical order, smallest to greatest.
The A practice number 3. Smallest to greatest, go. The A practice number 3. Copy them down from smallest to greatest. Probably hit you over the head with it. Okay, so just the practice problem number 3. You got them written down? Come on, it's like 9 numbers. Is it 7?
It's 7.
Now, just based on appearance, does there appear to be a number in that list that doesn't quite belong? 9.8 kind of seems out of place, doesn't it? But according to the book's definition, you would just say, oh, yep, that's definitely an outlier, when it might actually not be. Okay? Okay, I need you guys to look it up at the screen. If I change the 9.8 to 9.0, would that still seem out of place?
Yeah.
But 9.0 is actually not an outlier. 9.8 is an outlier. How do you tell the difference? There needs to be a way to quantify. You need to. There's a little formula. So here's, the book doesn't show you it, which I think is ridiculous. You need to find Q1 and Q3 for this set of data. This is what you're going to have to do on your test and on the homework problems. if you're trying to decide if a number is an outlier, this is how it needs to be done. You need to arrange the numbers in order, and then find Q1 and Q3. Do you remember how it is we did that? You gotta find the middle, and then you find the middle of the middle, right? And the middle of the other middle. What is the number right in the middle of this? So this is Q2, this is the median. So now you've got these four numbers right here. This represents the bottom half of your data. What would be the number right in the middle of these four numbers?
2.6.
You guys hear that?
Yeah.
So 2.6 would be called Q1. Well, 2.3 to 2.9.
And then Q3 is 5.2.
Yep. Q3 would be 5.2. That's right in between 5.9 and 4.5. I'm actually going to stop you here. Get your calculators. Grab your calculators. Turn them on. If you have a graphing calculator, at least turn them on. And just so you guys can get out of your desk, I want you to stand up while you watch this. Everybody stand up, but keep your calculators. We're going to follow along, so get your calculators in your hand and follow along. You guys remember back in Unit 2 or Unit 1, it was way back at the beginning, I had you type in numbers into a giant list. Do you remember where that was? It's L1 and L2 and L3. Do you remember where those are?
Yeah.
Okay, so go to Stat. Now where do you go?
Edit.
So go to Edit. If you have numbers in your list, you need to clear out those numbers. So one way you can do that is scroll up to the top of the list, hit clear, and then scroll down.
Or enter.
Okay. Now, type in these numbers 2.1, 2.3, 2.9. So I'm going to do 2.1, 2.3.
The whole list?
So the whole list, 2.9, 3.0. Type in all the numbers, 3.3, 3.4, 4.5, 5.9, and 9.8. You got them in there? Now, I don't know if I showed you this before, so I'm going to show you now. I don't want you to do this because it's already in order. I'm going to type in this list out of order, and I'll show you. Did I show you how the calculator can put it in order for you? No, let me show you. I'm going to type, let's see, 2.3, then 2.9. Make sure I don't forget one. 2.1, 3.3, 3.0, 3.4, 5.9, 4.5, and 9.8. I think I got them all. These are not in order, yes? All right, check it out. Go back to, well, you're just going to have to watch because yours is already in order. Do you see any one of these options that would put something in order for me? Sort A means sort ascending. That means smallest to biggest. Sort D means sort descending, biggest to smallest. Which one do we want? So that would be sort ascending. So I'm going to hit option 2. Now it asks me for what list. What list was it? So hit second, then the number 1. So now if I go back to my list, check it out. It's in order. Anyway, here's what you really need to watch. Back in Unit 2, once you typed in your numbers, you had to go to another menu to have it come up with the equation. Does that sound familiar? Where was that menu?
Stat, calc.
And then it was on calc, wasn't it? Now you guys back then used quadratic regression and cubic regression. We're not going to use any of those because we don't want an equation of a line. You need to use this first option here, one variable statistics. So hit enter on one variable statistics. Now, depending on how new your calculator is, your screen might look like this. If it does, hit enter 3 times. 1, 2, 3. If you have an older one, then your screen is going to say one variable stats and then a blinking cursor. you need to hit second and then the number 1 to tell it which list to use. And then hit enter. Brings you to this screen. Scroll down to the bottom. Check it out.
Wow.
What does it give you?
All that stuff.
Q1, it gives you the median. It gives you Q3. It gives you the minimum value, the maximum value. Okay? Oh, before I forget, you need to write this down in your notes. The very top one. You see how it has an X with a bar above it? That's your mean right there. The X with the bar. That's your average. So with all 9 of these numbers, the average is 4.13333. That's what X bar means. So even though this wasn't very difficult to calculate by hand, we figured out the Q1 and Q3 by hand. Your calculator can do it for you. Okay?
So, let's continue. We've got Q1 was 2.6. We got Q3 was 5.2. Next thing you calculate is what's known as the IQR. It's just Q3 minus Q1. Write that down. IQR. It's Q3 minus Q1. So in our problem, it would be 5.2 minus 2.6, which is 2.6. IQR stands for inner quartile range. Inner quartile range. Now, one of you, I can't remember who it was, one of you mentioned the range. The range of a set of data is the biggest number minus the smallest number. That's the range of the data. So the inner quartile range would be quartile 3 minus quartile 1. It's the inner quartiles. Anywho, once you've calculated the inner quartile range, and this is just an arbitrarily chosen value for statisticians to quantify how far away a number needed to be considered an outlier. There had to be some kind of a boundary to set before you say, all right, that's an outlier, that's not. And so they chose 1.5. So you take the IQR value and multiply it by 1.5. So again, for our problem, what was the IQR value? We take 2.6 and multiply that by 1.5. What do we do? What is it? 1.3? Should be something.
I did times 0.5.
There's times 0.5. It should be 3 point something.
Yeah.
3.9. So I know it's a lot to keep track of, but they are very simple calculations. You take Q1 and Q3, you subtract, and you take that number and multiply it by 1.5. Pretty much that's all we've done so far. Okay? Now you take that value, you add it to the end of Q3, and you take it away from the end of Q1. So you add it to Q3, you subtract it from Q1. You take this value, 3.9, you add it to Q3, and you subtract it from Q1. So Q3 is 5.2, and if you add 3.9, what do you get? That's your boundary. Any number bigger than 9.1 would be considered an outlier. So is 9.8 an outlier? Yeah, what about 9.0? No. Even though 9.0 seemed like it didn't belong, it's really not considered an outlier. Now that's on the top side. On the bottom side, at once. Sounds important. Kristen! You have been chosen to go to G. So Q1 is 2.6. And if you subtract 3.9, it'd be negative something. Negative 1.3. So any number smaller than any number smaller than negative 1.3 would be an outlier as well. So that sets your bounds for what is and what is not an outlier. Okay? So let's go through this process one more time.
So, sorry, those numbers are outliers, or is it one bigger or smaller?
Bigger or smaller than these.
Okay, so 9.1 is not an outlier.
Yeah. So let's go through the process again. The first step was to find the IQR. It's Q3 minus Q1. That gave us 2.6. You take that and you always multiply it by 1.5. You take that value, you add it to Q3, you subtract from Q1. That sets your boundaries. Any number outside of that boundary would be an outlier.
Okay. So let's see. Any number bigger than 9.1 or smaller than negative 1.3 is an outlier. So, is 9.8 an outlier? Sure.
Yeah.
Sure is. So why don't you try to practice problem number 4? Try practice problem number 4 on the middle of page 5.
So is that all you have to do for these bound problems, or do you need to also apply?
Is this right? So suspect the next order.
So you need to find Q1 and Q3. So go back to stat. And then calculate. And then one variable stats. What does your screen look like? So now type second and then number 1. That tells you what list to use. And you typed everything into list 1, I'm assuming. So now hit enter. Okay, so scroll down to the bottom. Well, then you need to go through the process. You need to find the interquartile range.
You're supposed to hit stat again, so did I go back to apps and then hit stat, or?
You see across the top those options there? It's probably going to be under calculate. So hit F4, and there's your one variable stat, so hit enter on that. And then it was list 1, right? So now you hit the number 1 there.
And then
Enter.
enter.
Argument must be a list. You shut your mouth.
You probably should. Yes. I know.
You told them that?
Talking about. I have to mess around with this. Let me mess around with it for a second. Okay, guys, tell me the numbers real quick for the. Well, no, just the numbers in the list.
17, 21, 19, 10, 15, 19, 14, 0, 11, 16.
All right, so I got the numbers in order, or I've got the numbers typed in. Go back to stat, calculate, one variable stat. So I'm getting Q3 is 19, Q1 is 11. Is that what you were saying? So what's the IQR? What did you guys get for IQR? Well, the IQR is 8, and then you multiply it by 1.5, and you get 12. So, you guys with me? If you take that value 12 and add it to Q3, you get 31. Anything greater than 31 would be an outlier. If you take 12 and subtract it from Q1, you're going to get negative 1. Anything less than negative 1 is an outlier. So is 0 an outlier? Anything less than negative 1 would be an outlier. Because 11 is Q1. If you subtract 12 from that, you get negative 1.
So it's Q1 minus 12?
Yep. So 0 isn't actually an outlier. Okay? That's how outliers work. Any questions on outliers? You find the IQR, you multiply it by 1.5, you add it to Q3, subtract it from Q1, and that sets your boundaries for outliers. Okay? You seen this before? I don't want to spend a ton of time on this because I know you've seen it before. Just draw a picture of it and let's move on.
Oh, that's the box of yours?
Just draw a picture real quick so we can move on. Listen. Probably. Box and whisker plot tells you pretty much 5 things. It's more than just a cool shaped graph. The end of the left whisker is your minimum value. The left side of the box is Q1. Wherever this line happens to be is Q2. The right side of the box is Q3, and the end of the right whisker is the max. A train? It looks like a train?
Obviously.
It looks like a box with whiskers.
But how's that a train? It's not a train. Why don't they call it the box?
So, to make this more accurate, you guys, you're not just going to have a box and whisker plot. It needs to be above a number line. Because if you're just looking at the box and whisker plot, how do you know what the minimum is? Or how do you know what the maximum is? You've got to have a number line underneath it to give it value. So let's say that this was 40.
Let's say this is 40, 50, 60, 70. Now do you see how these have values? So what would the maximum be?
Like
120 to 119. The minimum value instead of that would be maybe 42. Q1 would have been 60, Q2 71 maybe, and Q3. So you have to have values underneath it to give it some kind of a scale.
Check this out. Turn your calculators back on. Well, I guess you can follow along assuming that you typed in those numbers, 17. So whatever numbers were on problem 4, if you've already typed those in, look at what you can do. Hit second. You guys with me? And then y equals. Hit second and then y equals. It brings you to what's called the stat plot menu. Okay. Hit enter on option 1. Turn the plot on. And then the next option down asks you which type of plot you would like to plot. We can have just a bunch of dots. We can have a connected thing. We can have a bar graph. And check it out. Your calculator can plot box and whisker graphs. So I'm going to make sure this one is highlighted. I wanted to use list 1. Okay. Now, frequency 1 just means every number that I've typed in occurs with the same frequency, 1. You usually don't have to mess with frequency. Before you hit graph, go to zoom. Actually, hit second quick, and then zoom. Scroll down to option 9. Zoom stat. That creates a window that is centered around the statistics you typed in. Oh, I forgot to clear out my y equals menu. So I've got a box and whisker plot on top of a funky looking graph. There it is. There's my box and whisker plot. Okay. Just looking at your data in question 4, what was the smallest value on your data?
0.
That's why the left side of this goes all the way to 0. What was the largest number?
21.
So this right side of it goes all the way to 21. If you hit trace, it tells you what the median is, it tells you what Q1 is, it tells you the min. Kind of cool, huh? Anyway, calculator can do a bunch of cool stuff. I don't think we need to spend any more time on box and whisker plots, except for just you got to remember one thing. What 5 pieces of information do you need for a box and whisker plot? 5 pieces of information. Median? You need quartile 1, quartile 3, the min and the max. Okay, all 5 of those can be found on the calculator. All right. I want you guys to stand up for a second before we do this last part. We have one more part of this lesson. Stand up.
Okay.
We got to talk about percentiles. Walk down to that drinking fountain and come back.
I have everything typed in the way it's correct. It's like I checked the window. I don't know what it's trying. So it didn't touch it.
Problem here is your Y min and Y max. There should be different values. I'm going to say 10 to 10.
Maybe.
Yeah, that works.
Okay. I don't happen to have
Some setting got messed up, but it should be okay from now on. Number 10.
Number 10. On page 9. You have to find mean, median, and mode. Well, I guess first it asks you if there's an outlier. One second. Yep. Did 54 turn out to be an outlier? Yes. Okay.
All right, if you would please tell me the numbers that we're dealing with real quick.
16, 17.
Well, hold on. Sorry, I wasn't ready. Jump the gun. Ready, go. Couldn't keep up with you. I got to 16. 16, 17, 18, 19,
There's 2 18.
another 18, 21,
20.
20,
22.
22,
54.
54, 23,
8.
and 8. Okay, I've got those. With the outlier, the average was 22.8. With the outlier, it was 22.8. Okay, and the median was 19.5.
Yeah.
So if I want to go back and calculate it without the outlier, just go to Edit, go to your list, and take out the outlier. So just delete the outlier, go back to Stat, calculate. So without the outlier, it was 19.3 for the average. And the median is still 19. So the outlier made the average closer to the median.
Just do much lesser with a better calculator.
I know you do it on that thing. I just